The Metis Tech Show.
Welcome to the Metis Tech Show, a show for HVAC professionals by HVAC professionals.
I like how you guys bounce back and forth between heat pump talk and food talk.
The Metis Tech Show.
Mitsubishi.
So, before we started recording, you were talking to me about Portuguese food.
Yes.
Is there a favorite of yours? Or?
Yeah, I love myself some Portuguese food. They're in Fall River, obviously. I'm from the East Providence, Fall River area, so there's a lot of Portuguese food. There's actually my favorite meal would be like a bife à casa.
Okay.
So bife à casa would be steak with either the egg on top. You can have a ham or prosciutto, rice and fries with a nice sauce. I think it's really the sauce that makes it to me, for me at least.
Yeah.
If you don't have a good sauce.
Yeah. Well, that's the thing is Paul has brought us to a place in Hudson that does it's a Portuguese restaurant, and we had something similar where it had the rice, the fries, and the steak and everything. And the sauce like kind of just soaks into everything, and it's like a game changer. It really is. Totally change the flavor. We went to a place in Jersey, and they used prosciutto. I don't know if that's the standard, but it was kind of a unique take. And they had what was called Spanish potatoes, which it wasn't French fries, but they were like a fried potato, but they were a little bit almost like a potato wedge.
Oh, okay.
And they're a little like thinner than a potato wedge, but it was a similar shape. Yeah. And so I just figured that was the standard. But then everywhere else that we've gone has been the rice and the fries.
Yeah. There's a place in Fall River that I genuinely love is Marisqueira Açougue. Okay. And they have this steak. It's called a beef açoriana.
All right.
But it's a white sauce. It's not like your normal like wine sauce or brown sauce. It's this white type of creamy sauce that they make.
Okay.
It's amazing.
Yeah.
Amazing.
Where is this?
In Fall River.
It is in Fall River. So right next to Steve's house.
Yes. So we'll have to get Steve and Paul to go there.
Yeah. I'm sure they already know about it, but if not, we'll definitely have to let them know because they love that stuff. We brought up the Portuguese food. You said it was one of your favorites. Are you Portuguese?
Very Portuguese.
You're very Portuguese.
Very Portuguese.
And so for full disclosure, what's your last name?
My last name is Shav.
No relation to Paul?
There is no relation there. Are we from the same island, though? Yes. We are. Yeah. Are we related? No.
Yeah. I made this joke to Paul and Steve, but I never thought that working in Massachusetts as an Irish guy, I'd ever be a minority, but it is official now. 3 Portuguese guys and 1 Mick all working together.
You got it.
But yeah, I mean, the Portuguese food is really good and filling. There's a lot of starch in the
very heavy
in the beef à casa. Yeah. And fish. There's a certain type of fish that I noticed they use quite a bit.
Yeah, we're big on codfish.
Okay.
We're huge on codfish. I like codfish. You know what it is? It's like one of those things you're raised with it.
Yeah.
You know what I mean? It's just you get used to it.
Yeah.
There's so many ways to make it too. So it's like even if you don't like the dried cod, maybe you like a fresh cod. There's, you know what I mean? There's so many ways to make it.
Yeah.
It's good.
I think last time we were there, we had cod cakes. This is the one that's near the training center. It's like 20 minutes away. He had ordered these cod cakes, and then there was this. It was actually really good. It was this almost looked like a boat, and there was a big piece of sausage on it. Oh, and then they lit it on fire, and it was so good. What is it?
Chorizo bombeiro.
Yep, that was it.
It's amazing.
So good. I was actually glad he got it because like I said, I don't like the cod cakes. So when I saw that, I was like, okay, I have my little appetizer. And I had to try not to go crazy on it because it was so damn good.
It's so good.
Yeah. But Paul and Steve are not here today. They're at the national sales meeting with about half of our other instructors. So I thought it was a good opportunity to have you on for your maiden voyage on the Metis Tech Show. Why don't you introduce yourself, a little bit about yourself, and what you are doing for Mitsubishi?
So my name's Eddie Shavs. I'm going to be the Boston instructor for the training center. A little bit about me. I'm Portuguese, which you guys already know. Big sports guy, so you can assume Portuguese soccer is huge. Love the Philadelphia Eagles if you can't see the hat. But yeah, I'm going to be teaching, and I'm also going to be learning. You know, my first couple months is going to be a lot of learning. I'm going to be soaking in all the information and then hopefully teaching everybody else.
Yeah, that's awesome. Were you a tech before you started here?
Yeah, I was a tech for 6 years. I was a service technician in the Providence area. I really enjoyed it, honestly. I loved being on service. All I did for my 6 years was service, but I loved figuring out. It's like a puzzle. You know what I mean? You're always trying to figure out what's wrong, and once you learn it, it's just such. I don't know. It's such a great accomplishment. You feel great after you learn what the problem is, and now the next time you see it, you know what it is. You know what I mean? It's just
definitely
it a lot.
Definitely a lot of fun, and that was kind of my experience too. Was I did service for a while, and I was working on heat pumps for a while before I started installing them. Yeah. It was probably like the first 2 months that I was ever in HVAC. I worked for a company that only did oil and gas, and by chance they had a ductless install that they did. And it was like nothing I ever did again. You did it one time and then never again. And so I got this one like crash course doing that installation and then didn't see it again until I switched companies and went to a company that did everything, did the AC as well. And I went right to service. I was mostly just fixing them and doing repairs and still mostly oil and gas, but finding leaks and all that stuff. And only after I'd been doing that for a while, did I talk to my boss at the time, who I got along really well with, and I told him, I'm like, I should probably do some installs so I can just get more exposure to how it all goes and why we see these problems after. Because most of the service calls you end up with are related to leaks or refrigerant management issues. Yeah. So I'm like, well, how is this happening? Because if you're not the one that's making the flares and pressure testing and triple evacuating, like how are these things getting missed? If you only do service, you don't know. So I got to do some installation. Basically spent a year on installation just to get the experience, and then went back to service.
But I agree with that though. Like I honestly, when I first started, obviously everybody tells you about install. You're like, oh, you're going to be in an attic. You're going to be here. You know? And it's like, I don't want to, you know what I mean? You don't want to go into install. You want to go to service. But if I could go back now, I think I would like install first so I can see how they're all installed, how it all comes together, and then work on them. You know what I mean? Because then it makes your life so much easier that way.
100%. And I've always been a big proponent of not having teams of installers and service techs. I think that a lot of the companies I worked for, everybody did everything. There was only one really that I worked for where there was an install team. Because the thing is even the camaraderie aspect of it is like, we didn't really talk to the installers very much. We'd see them in the morning, they were packing up, and then we wouldn't see them until the end of the day, maybe, or sometimes they'd still be there or they'd get done early. And so we didn't really get to know them as well as I think I would have liked. If everybody does everything, I think you get more well-balanced experience. And I'm sure you've been in this situation. We used to deal with it all the time is if you have that segregation of installer versus service guy, the service guys are always like, oh, our damn installers did this or did that. And then these poor installers, they're like, well, the sales guy told me to put it here, so I had to. And they don't know enough to be like, well, the cover, you don't want to block the electrical cover because they don't have the opportunity to ever work on the equipment once it's in. And so having the experience of both is, if you're a service guy, service space is really important. I don't want to be, playing Gumby to get around to see the control board. If an installer has no idea where that control board lives or doesn't realize how often it's going to be accessed, they may not pay attention to where it goes. If you've already done it and you've seen how important it is to have that service space, when you go to do an install, you're like, I don't want to put it here. This is going to screw us over later. So I think there's a benefit to doing both that you don't get to see.
I'll take this opportunity now to say that I was that guy. So I'm sorry to my installers. it happened.
Oh yeah. We all do our fair share of complaining. So you said Portuguese soccer.
Yes.
Have you heard the Portugal song that's like going viral?
Yes.
Oh my God, it's such a good song.
Very good.
I found it on Spotify and I saved it and I listened to it at the gym. And I saw a really funny video. It was a guy and he was I would guess Japanese, but he was Eastern Asian. And he's like, when the Portuguese FIFA or the World Cup song comes on, it makes you question your heritage or want to change heritages because it's such a good song. It's such a bop. So like, when I heard it the first time, I'm like, oh my God, I think I might be rooting for Portugal. Yeah, that's good. Welcome everybody to the Metis Tech Show. Myself and Eddie will be on this one today. Paul and Steve are at the service meeting, as well as most of the other instructors. And what we're going to talk about today is the last couple episodes, we had brought up that we had an issue with one of our smart multi units in the training room here in Boston. And we put it out to the listeners to say, hey, what do you guys think? We gave some scenarios just to recap. When the system wasn't operating, the high and low pressure sat at around 400 on the high side and like 354 on the low side. When the system was operating, it didn't sound right. Compressor sounded off. And then the unit, after about 10 minutes or so, threw a 1302 error code. And this all happened after we had added an indoor unit to that smart multi.
Gotcha.
So the system was recovered, repressure tested, triple evac'd, all that good stuff.
Yeah.
And then the total charge was added back in. So we just were curious what people thought, had some ideas. We found out pretty much the same day because we were able to get them back to check. But I just thought it'd be a good exercise. And because of the likelihood of this maybe happening in the field, I figured we could do an entire episode on it.
Yeah, smart. Can I give you my guess?
Yes.
My guess is going to be it's overcharged.
Overcharged.
That's my guess.
Yeah. Yeah.
I'm guessing overcharged.
Yeah. We'll go into it and maybe talk about when we would think it's an overcharge and what actually happened and because in a lot of ways it's a really good guess. And actually some of our listeners did guess that. Nice. So we'll cover all the possibilities, and some of the responses that we got were great. And I think people were on the right track. Yeah. So we'll get into it and see exactly why we came to the determination we thought it was and how we were able to confirm that. So some of our listeners emailed in, and I have them in front of me. The first one was from Nick, and this was the first email that he sent us. And if you can't see it because you're listening only, it's about a full page email. Wow. And in there was about 4 to 5 guesses. So last episode we told Nick, pick one. So he did. He said, okay, I'll pick one. They closed the service valves when they installed the air handler, pressure tested, evacuated, and put the additional charge in, but forgot to open the valves back up. And then he said, my only question would be, why wasn't operation tested when work was complete? Which I think is a good point. I mean, in general, part of the commissioning process after you do something like that would be to run it.
Who's Nick trying to get in trouble?
Yeah, that's a good point. But yes, I mean, it's a great point to make, which is if you do, even if it's adding on to an existing system, you really should go back to, an initial startup, go through it like it's a brand new system and just make sure everything's working. It wasn't right. The valves were open, but a lot of good ideas there. We're going to get into what exactly happened. The next one is from Brian, and he said, I will take a stab at your quiz, and he thinks it was a bad compressor, which would also be a good guess. We talked about the noise it was making. Yep. We talked about the fact that pressures were off, so sometimes that can be due to the compressor free spinning or something like that. So that was a good guess. Justin, he's from the Chicago area, said, hey guys, taking a shot at this with the info you gave out in the last episode. He said that the installer left a ball valve closed after the installation was complete. Always appreciate the knowledge you guys share. Take care, which is another great guess. Nice. And we're going to talk about the 1302 in a minute and why these are all such great guesses. And then we had one on YouTube commenter, and he had mentioned that he thinks moisture was left in the system. Oh. So maybe that was causing part of the issue. It wasn't properly evacuated, didn't get all the moisture out, and some moisture remained in the system. And so what we found was that the system had a ton of nitrogen in it. Oh. That was the issue. We had a ton of nitrogen in that system. Now, I don't know where exactly it was left, but if I had to make an educated guess based on the A2L smart multis, my assumption is that the outdoor unit was completely full with nitrogen when the refrigerant charge was added. Oh. So the things that led me to that were the fact that they did recover the entire system to add that head, because they did a lot of repiping work too. Mm-hmm. So they recovered the entire system to add that indoor unit with those solenoid valves that are now on the liquid and gas valves that are closed when the power's off. If you don't know about those and you treat it like a standard system, you could 100% leave your entire nitrogen charge inside that outdoor unit. Unless you know that they exist and you think and you plan accordingly, there's a high potential for that. If you treat it like a standard multi-port system, you'll probably leave some nitrogen in that system.
If you read the manual, would you know?
Yes. I mean, the literature is in there about the solenoid valves and what they do and how they behave. The problem is that there isn't a procedure that's listed in the manual for like a proper pressure test, triple evac. So the information is there, but it would be, sitting on the on the 5-gallon bucket and reading everything to really get an understanding of how it all works. But we're going to talk about it because, like I said, I could see this happening in the field. So I want to cover how we could avoid that for those who listen. The other thing is that I totally forgot what I was going to say. Anyway, why don't we read what the 1302 actually is and why that might have caused what we dealt with.
So 1302 is a high pressure trouble or thermal protector trouble. So causes for that would be a faulty operation of stop valve, so it's not fully opening. A clogged or open pipe, a clogged or broken pipe, malfunction or locked outdoor fan motor. Didn't even think about that. Dirt of outdoor heat exchanger, remote control transmitting error caused by noise interference. Let's see. Decreased airflow, clogged filter, or dirt on indoor unit. All right.
Yeah.
Indoor LEV performance failure. There's so many options here. There's really a lot of options.
Yeah, and so the 1302 is a high pressure fault essentially, and so that's why a lot of the potential causes are what you would think in a standard HVAC high pressure fault, which is restriction. Right? In our case, it's a LEV is our metering device, but the LEV is not performing properly. In this case, it would be closed. It's stuck closed. Yep. So now we are deadheading against this LEV. It's going to elevate our head pressure. Yep. We get the high pressure fault. Your outdoor coil is dirty. We're not heat rejecting anymore because there's so much dirt. Or I've seen like lint and stuff inside those outdoor units. And if you can't have the airflow through that coil, you're not going to heat reject. The pressure is going to stay up, and eventually you can get that high pressure fault.
Back to installers real quick. Yeah. Why install a condenser right in front of a dryer?
By the dryer
right?
vent.
I'm just saying, installers, I love you guys, but come on.
Yeah. Well, if you don't ever have to spray them down. But yeah, so it's the same thing that in any HVAC system that would cause a high pressure situation. Your outdoor fan's not operating properly. Your coil is dirty. You have metering devices that are stuck closed. All those things can lead to that. Ball valve stuck closed, or king valves on like a unitary system. They're stuck closed, and that's why we get that high pressure fault. So no different with our equipment. The reason why we got it obviously was because nitrogen is a non-condensable. So when we're trying to compress a non-condensable, it's going to elevate the pressure inside that system. And I think with how much nitrogen was in that system, it was going to have a hard time. And you could hear it almost immediately. When the compressor came on, there was a noticeable noise that did not sound normal. So that was my big clue, was something is causing that compressor to make odd noise. And then when the system was not operating, to have those standing pressures so high. A 402 on the high side, and then it was like 354. I'm going off of memory, so it might have been slightly different, but I know that it was like over 400 on the high side and like 350s on the low side. And that was in the training center. So one of the big hints that I kept giving out during this, because I had the suspicion already, was our outdoor unit is inside the training center. And the training center's room, which would be our ambient temperature, was 71 degrees roughly. So is it possible to convert a pressure to a temperature?
Yes.
Absolutely,
we
right?
have a beautiful PT chart. PT chart,
yeah. So the PT chart is really what our pressure should be when we're equalized. And so one of the big hints or tips that I like to give out to people is, if you are worried that a system is drastically overcharged, drastically undercharged, or has non-condensables in the system, don't run it. Just look at the pressures. And in most of our equipment, in this case, it was a smart multi. We don't even have to hook up gauges. We can just hook up maintenance tool, or we can use the dip switches on the outdoor unit and see what those standing pressures are, and then convert them to a temperature. If they are not the ambient temperature, something is wrong. That's not normal, normal condition. So for context, I'm going to pull up the PT chart. So like I had said, we had 400 PSI on our high side, and it was about 350 on our low side. So if we look at this PT chart for our 454B, I had to pull up the right refrigerant chart, but at, let's say about 400 PSI, the closest here we have is 395.9. What's my temperature? 120 degrees.
Definitely wasn't 120 in there.
No, and it wasn't 120 in the room. So what is going on there? Why we have this higher saturation temp on the system? And now our low side, like I said, was about 354. The closest comparison we have there is 346. It's fairly close, and it's giving us 110 degrees. So both of those saturation temps, when the system is equalized or not running or stagnant, should be the ambient temperature. And the way I like to think of it is, because I used to do this a lot, is, do you remember with 410A, if you were outside on like a mild day, 70 degrees, when you hook up to that 410 tank, it's almost always like 200 PSI. Like
easily.
Universally, when you hook up to 410A on a normal day, 70 degrees, it's 200 PSI. So that's your saturation temp, right? That's how we know what the state of that refrigerant is based on pressure and temperature. So my experience has always just been like on 70 degrees, I should see about 200 PSI. So when it was 70 degrees and I was seeing 450 PSI, I'm like, or 405 PSI, I was like, something was not right. I've never seen that before. It's abnormal. Now, you had mentioned something which was overcharge. Right. And overcharge was my first guess too, because why the heck are these pressures so high? But to me, what was interesting was that the pressures were different. So having a different pressure on my high and low side while equalized, and in our case, SV1A is, or SV1 on a smart multi is open, which means that they're open to each other. So they should be equalized. The fact that they weren't leads me to believe that on my suction side, I had either more or less nitrogen, probably less nitrogen than I did on my high side.
Makes sense.
And that's why my pressures were so different on either side of that compressor. So that was my indicator too, is why would standing pressures be different? Something has to be causing that. And it's just the existence of a non-condensable. I did remember what I was going to say earlier, which was when they opened up the outdoor unit, they pushed in the Schrader, and it just looked like air was coming out for a while. And so that was how we kind of confirmed, like, there's definitely some nitrogen, definitely some nitrogen in there. And the installer, or the guy who came out to fix it, he said that he hooked up his recovery machine and didn't turn it on, and it sucked out a bunch before he even had to put on the recovery machine to pull the rest of it out. So there was a decent amount of nitrogen in there. And the fact that he wasn't seeing any of that liquid, refrigerant gassing off is a good indicator that there was something other than refrigerant in that pipe there. So
now, quick question that I have for you. Are you causing, in that situation right there, it was only ran once quickly, did you cause any damage to the compressor?
I don't think so. I think it's probably all right.
It's minimal.
If I had known, I would never run a system. And that's kind of something that we started to talk about, but I was going to get into, is that if you have suspicion of those things, don't run it. And now that we have a way to at least get an idea without having to run the system, and that's just comparing those saturation temps to the ambient temp, there's ways to find out. And this actually happened with Steve one time. He was in San Jose doing a class, and they had a city multi-unit on a cart. So it was one big city multi on this gigantic cart that the UA uses, and it had a leak. So he was trying to figure out what was going on with it. And now, mind you, this cart is outside in San Jose, California. And he sends me one picture of maintenance tool. It's a single minute of maintenance tool. And the standing pressures were like 118 PSI. Ambient temperature was in the 90s. And I said, you're undercharged.
Very.
And he's like, oh, yeah, that makes sense. And it was the same thing. His saturation temps were like 32 degrees, 34 degrees. And then his outdoor temp was 90. Like, it's no two ways about it. There's not enough refrigerant in that system. So it is really helpful. I've used it in the past. It makes that kind of diagnosis really quick. Obviously, if a system is slightly overcharged or slightly undercharged, you're probably going to miss it. It's not going to be apparent. But in those situations where you have non-condensables or you have vast overcharge or undercharge, you can see that. And one thing I wanted to show is this is our maintenance tool. So I'm showing a city multi-unit because city multi will actually do the calculation of the saturation temperature for you. So when you look at the outdoor unit, which is that top box, you'll see on the second row 63 HS1 and 63 LS. That is the high and low pressure. And you'll notice that one is 159.3 and one is 160.7. So we're equalized. System's not operating. The control mode is in stop. So the compressor's not running. Just below 63 HS1 and 63 LS is TC and TE. And we see 55 degrees. If we look at my TH7, we're at 67 degrees. So this is one of those situations where, am I undercharged? Maybe a little bit.
Yeah.
It's possible,
Minimal.
a little bit.
Yeah.
But that to me is not going to raise a ton of red flags, because if that system was just operating, we might see some slight differences there. The ambient temperature, because it's in a classroom, we could have a fan coil that was blowing on it, and it's changing the actual temperature. So in a training environment, that's not going to concern me too much. If I was on a job site and it was truly 67 degrees outside, but my saturation temps were 55, I may be in a point of going back to DSB and making sure that system was charged properly. But out of curiosity, right, our 63 HS1 and 63 LS were 159 and 160. So that was my high and low side pressure, showing a TC and TE of 55 to 56 in that range. And so I pulled up the PT chart for R32, and we'll see that around that 159.5 PSI, we've got 55 degrees.
Yeah.
So the TC and TE is just the saturation temperature. And I use those numbers religiously. Yep. When I'm diagnosing a maintenance tool system, it's very rare for me personally to use the high and low pressure as my gauge. I'm almost always looking at TC and TE, the saturation temp. And part of that is just knowing typically where we want to be during operation. And it's a lot easier for me to remember 3-digit numbers than, like a 120 or 32. It's a lot easier for me to remember than 318 and 102. So it's just having used maintenance tool a lot, those are the things that I do is I really am looking at the saturation temp of the refrigerant.
The maintenance tool alone is just so impressive. You get all the information there.
Yeah.
It's awesome.
There's a ton of good information in there. Actually, on that, I just wanted to bring that up because you bring up a good point, because I noticed this when I looked at this maintenance tool, that if we go down to the branch controller, which is the second box, SC1 is showing negative 12 degrees and SC6 is showing negative 12.4. And we calculate the SC1 and 6, that's just subcooling that is going on in the branch controller. Now, mind you, the system's not operating. Yeah. But when you look at the standing pressures, we've got 159 at the branch controller as well, which means that my PT chart is going to be around 55 degrees. Maintenance tool will show that. PT1 and PT3 shows the saturation temperature for those pressure transducers. And all they're doing there is comparing them to thermistors that are actually on the BC. So SC1 is comparing PT1 to TH11 in this case, or T1 if you have a 410 version, and it's showing 67 degrees. So we're doing the same math, saturation temp compared to an actual measured temp. And because the measured temp is the ambient temp, 67.1, it's showing negative subcooling. Yeah. We should be below the saturation temp for subcooling. We're above it, so it's showing a negative subcooling. So in this case, like I said, in a room training center, it doesn't freak me out. If I was on a job site and seeing this, I would be a little bit concerned with the pressure being so low with a 67 degree room or ambient temperature. So that's the way that, we do things with maintenance tool, and I live and die by those saturation temperatures. It's one of the reasons why I talk so much about it in class, and even on the indoor units, we calculate the superheat and subcooling. And I tell people sometimes, like, pay attention to that superheat and subcooling, but remember that we're just getting those values based off of the temperatures. So you might have a superheat that says 13 at an indoor unit, and you go, oh, it's not in that 0 to 10 range, something's wrong. But if you look at the temperatures, it's got a 45 degree coil. It's probably doing okay, right? It's not going to concern me as much. Yeah. So knowing both and knowing when to check for both and what's important when you're using maintenance tool is great. In this case, it got me to that non-condensables very quickly, because as soon as I saw those standing pressures, converted them to a temperature, I'm like, oh yeah, we're way out.
Something's up.
Yeah. So, so this is going to happen probably to more than one person. It happened to us, and we were a training center. It's probably going to happen in the field, and that's because of those liquid and gas shutoff valves that exist on the Smart Multi. So the Smart Multi now has liquid and gas shutoff valves, and that is to allow it to pump down in the event of a refrigerant error. So if one of our refrigerant sensors detects a leak or goes into air, like say the heater fails, or there's a capacitor on that refrigerant sensor board goes bad, it will communicate, hey, there's an error. I'm not adequately sensing refrigerant now, and it will put the system into this pump down. And so the way that works is the compressor comes on, the liquid line shutoff valve, it's a solenoid valve, will close, and we're doing a standard pump down that you would do on a unitary. You close your liquid line first, you run the system, it's pulling all that refrigerant in the line set and heads back to the outdoor unit, and then at about 30 psi, that gas valve will shut off. And now you have your refrigerant pulled entirely into that outdoor unit. We leave some positive pressure, and that's just because we don't want to suck in contaminants.
Yep.
So we want to avoid pulling into a vacuum and actually sucking in contaminants through that leak. So we leave some positive pressure, but obviously not enough to cause, potential for safety risks. So the fan will usually run for a little bit after it pumps itself down, and then everything stops. If it's a true M series unit, so wall mount, floor mount, one-way cassette, they make a constant high-pitched whine. So it's not like a beep, beep, beep. It's constant. One tone. Wow. It's like if you ever set off a security alarm and it's that kind of ringing that you can feel in your ears. It's like that. It's not as loud, but it makes a constant noise.
It's one of those alarms you can't ignore.
Yeah. No, like, you would know.
It's not like your seatbelt, the seatbelt's going off in your car. Beep,
no,
beep.
You can't turn the radio up on this one. And to silence it, if you were the homeowner, for example, to silence it, you have to push the emergency operation button, and that will silence the alarm. That's really only easily accessible in the wall mounts. The floor mounts, you have to pull the whole cover off, which like homeowners should be doing to clean their filters, but in reality, probably aren't. Yeah. So getting access to the emergency operations switch can be tough. One-way cassette's even harder because think about it, it's in a ceiling, and you have to drop the grill to find that button. So it's likely not going to happen. So homeowners will just shut it off. And that's okay, because once you shut it off, our liquid and gas solenoid valves will shut off as well. But that's the basic process. One thing that we learned over time is that the liquid line valve is what's called a bidirectional shutoff valve. Nice. So think of it like a solenoid valve that has a magnet that's pulling a stem out of the way when it's energized and dropping it back in place. But it has a check valve in it, which means that we can, and we're in heating mode, we can pump refrigerant into the outdoor unit, even if the solenoid valve isn't energized. Huh. So that is the direction of that check valve is to the outdoor unit. Yeah. If we're in cooling mode, that refrigerant would be trying to leave on that pipe and it would be hitting the check. So the solenoid has to energize to pull that check out of the way and allow the refrigerant to flow. And so, there's multiple ways to do this, but in the event that you had to completely recover a system, pressure test, triple evac, and recharge, I have a method of doing it that just keeps it as simple as possible. The check makes it a little bit tricky. It gives you more options, basically, but the basic and the easiest way to recharge the system and pressure test all those things is that after you've recovered the entire refrigerant, what I say is pressure test your outdoor unit first, and then pressure test the line set and heads. So you have 4 ports on that system, 2 on the outdoor unit, and then 2 at your service valves. So you are on either side of the solenoid valve at this point. So pressure test the outdoor unit and get it up to that 600 PSI, and then pressure test your line set and heads. Because that solenoid valve 4, even though the check is going against that 600 PSI, you have 600 PSI up against that valve. So when you pressure test the line set and heads, you'll get up to 600, and now you've got 600 on either side. So I always recommend now with the A2L version, don't close your service valves to do any repair work. Just leave them open because the solenoid valves are shutting off the system anyway. They're isolating the system. So leave them open the whole time. You pressure test the outdoor, you pressure test the line set and heads, and then when you go into your triple evacuation, do it from both sides. You can do it at the same time, right? So pull your outdoor unit down to that 500 microns, pull your line set and indoor units down to that 500 microns, and then when you go to recharge the system, start at the outdoor unit again, put the factory charge in the outdoor unit, and then put the additional charge in your line set and heads. Now, obviously, you're probably not going to be able to get the entire charge in that way, but at that point, you have filled that system with refrigerant. Yeah. The vacuum has now been removed, and now you can run the system and charge like you normally would to get the rest of that refrigerant into the system.
Doing it that way is great because then you're making sure you have non-condensables. You should be perfect. Yeah. You're doing everything the proper way. Yeah, I like that, actually. It's really...
The simplified way that I tell people is treat it like 2 systems. Yeah. Your outdoor unit, treat it like 1 system, and then your indoor units and line sets, treat those like a separate system. And if you do it that way, you have a better chance of success. The reason why I'm big on don't shut off your service valves is because there is about 6 inches of pipe between the service valve and that solenoid valve. And so if you isolate, there isn't any way for you to pressure test that section or evacuate that section. You're not going to get, especially on the gas side, you're not going to get You're not going to pull down because there's a solenoid on one side and a shut-off valve on the other, or a service valve on the other. So that 6 inches of pipe gets untouched. Yeah. So you have to leave those open to make sure that everything is getting evacuated. The reason I say doing the evacuating at the same time is because that check, technically you can pull all through the outdoor unit because the check, if you're pulling from the outdoor unit, it will pull through that check, and that's fine. But to speed up the process, you have 4 ports. So use them, pull them at the same time. Yeah. It's just when you're ready to charge the system, do the outdoor unit first. So you get all that charge up to your check, right? And so we have full refrigerant up to that check valve. Then when you do your line set and heads, it'll fill in the rest. So we're just making sure we don't leave any gaps in the piping. And there are other ways to do it. I've had guys in class who are like, well, couldn't I do this or that? And I'm like, yeah, technically you could. You 100% could. What I tried to do was just build a simplest, easiest, 100% chance of not leaving the condensables in the system. There are ways that you might think of that it might be a little bit faster. And if you feel comfortable with them, 100% take advantage of it. But you have to understand that not everybody in HVAC has been doing it for a long time, and they don't necessarily understand the entire concept of what we're trying to do during that process. And if we give them a simple step-by-step, outdoor unit first, pressure test, line set and heads, pressure test, evacuate both, charge outdoor unit first, charge indoor unit first. That's something that they can stick with. That's something that they can go with. If we say like, well, technically you could do it this way or that way, then they start to go, oh gosh, what am I even doing? So I think it's just easy to give a simple laid out process for them, just to make it as simple as possible. But you can see now that if you don't do something in consideration of those valves, like if you were to treat it like a standard heat pump, you will leave non-condensables in that system. You'll either leave nitrogen in there or you will have a section that didn't get evacuated, which could be air. Exactly. So that's why we kind of have to be aware of those solenoid valves inside the outdoor unit to just make sure we don't leave non-condensables. I don't think that's what the case here was. I think the case here was that they didn't know about them at all. And so the entire outdoor unit just had charge in it. They were probably trying to pull everything from the service valves. And unfortunately, you're not going to get it. Yeah, you're not going to get it out because of the check valve. The position of that check valve is not going to let you pull everything that nitrogen through the outdoor unit. So they got into a situation where they didn't know that. They probably only had their gauges set up on the service valves, saw that they pulled a deep vacuum, said, awesome, this is great. Let's go. Charged up the system, open up the service valves. Now you've got nitrogen, refrigerant in the system at the same time. And then they were probably trying to force the rest of it in there while it operated. And they're like, oh, this thing sounds weird. It'll probably quiet down once I get the charge in there. And it didn't work out that way. So mistakes happen. And I think that's why we do this show, is so that we can try to educate and avoid any of those mistakes for the guys in the field.
I personally feel like I learned a lot about the 1302.
Yeah.
1302. You learn a lot about honestly, this podcast, what I've noticed since I started listening is that the information is very, very, very valuable. Like even for me, like I personally, I didn't know about the 1302, right? But just by having this conversation, a quick 20, 30-minute conversation, I've learned so much. And now I can actually do a proper evac, and hopefully I'd never fall into these issues.
Like I said, mistakes happen. And, I guarantee you at some point in my career have left nitrogen in a system. But it's just a matter of, what can we do to help people have a higher chance of success. And you'll notice with that 1302, we just printed out one page, and there's this troubleshooting flow chart where it's like this yes-no flow chart. And the first page has a couple of them, but it's 3 total pages of yes-no. Oh, wow. So it has you check absolutely everything. So you should be able to diagnose what's going on. One of the things that was also added with the A2L equipment in series with the high pressure switch, which is what causes the 1302, is a thermal protector. And that's just a bimetal switch. So the way I like to think of it is like a furnace high limit. So right near the terminals, UV and W that go into the compressor, there's a bimetal switch that opens and closes based on temperature. So wired in series with that high pressure switch is the thermal protector. So if by the terminals, the UV and W terminals going into the compressor, if they get up to a temperature above 248 degrees, it's going to open that circuit. Nice. And you'll get this 1302. Now the 1302 is going to say high pressure trouble or thermal protector trouble. And so you just have to know, okay, which one am I checking? If it was a failed switch, if you weren't sure, like I definitely didn't get onto high pressure. I definitely am not in a situation where the temperature got up to 248 degrees. Do I have a failed switch? You would want to isolate your high pressure switch from that thermal protector, and then it's just a continuity check.
Exactly.
Am I open or am I closed? And if you know for a fact that that temperature of that switch is not 248 degrees, but it's not closed, then it's a failed switch. And that happens with furnace high limits, right? I've replaced tons of them where the high limit's 190, but it's not tripping at 190. It's either taking too long or it's staying open no matter what I do. So same process exists for that thermal protector, but it is laid out in the manual. You'll just go step by step and it will have you test all the things. I was a little bummed to see that one of the causes in there was not non-condensables in the system, but we can't catch all of them.
Yeah.
So just be aware of that. And really, those diagnoses are typically based on a system that was already running and installed. Brand new installs, anything could happen, right? So it's just stuff you have to be aware of.
I think with the 1302, I don't know if are we RTFM? Are we allowed to say that?
Oh yeah, absolutely.
RTFM.
Yeah,
you got to RTFM. You definitely got to.
100%. Yeah, I mean, and you're gonna see this. How long have you been here?
I've been here like a week.
A week and a day, right?
Yeah.
Yeah. So you'll see you get a lot of opportunity to read. And what we do as instructors is read. We read a lot of manuals. And so RTFM is basically my job description.
Yeah.
So when we have guys in class and they don't want to do that, I'm like, unfortunately,
it's your job.
You're never going to get to the point you need to be because the RTFM, and I'm very thankful for Mitsubishi in general because their manuals are so thorough that you can find just about any information in there. So I wouldn't necessarily recommend somebody do it just for the sake of doing it. But if you are on a service call with Mitsubishi, I would anticipate cracking open that manual. Go to MitsubishiPro.com, look up your unit. Typically with residential equipment, like a Smart Multi or M&P series, just go to the outdoor unit service manual and start reading.
Yeah.
Try to find a section that applies to what you're dealing with, but there's going to be some navigating and some reading, but it's all good information. So totally worth the endeavor.
100%. All the information is there. So you might as well read, learn a little bit. Can't hurt.
Nope. But yeah, that should do it on this one. I was hoping somebody would get it. To me, the moisture thing is as close as it gets. That is a non-condensable. Yeah. So they were right on it. So good job on that one. Just happened to be nitrogen in this case, not moisture, but still a non-condensable.
Was that one of Nick's options in his first?
Oh, that's a good question. Let me look it up.
I'm curious now too.
He said overcharge was the first suspicion, but I can't imagine overcharge that high. Low discharge suggests overcharge or bypassing a refrigerant. That was a good one. Possible they charged the refrigerant lines with the additional, but forgot to open service valves. Could it be head pressure got so high SV1 opened up to bypass, causing suction pressure to get high? No, he didn't get moisture. But he had lots of good guesses and all definitely things that I would check if I had a 1302. And that was the thing that was encouraging about a lot of the responses were all of them either looked up a 1302 or have seen it in the past or just took the scenario and tried to be as reasonable as possible. But they were all on it, which means that our listeners are smart guys. So
they're listening.
And ladies too. So I appreciate the feedback. But that's going to do it for this episode. I think we got to go. So what is the name of the place? Because you said it with the Portuguese accent.
That's the only way I know how to say it.
How would a Massachusetts?
Marisqueira Açores.
Okay. All right.
It's in Fall River. It's amazing. Shout out to Lucia. She's a great cook. She knows me by name. It's crazy.
Family? Or
no, I just go there too often.
I was like, because every time we go to any Portuguese restaurant with Paul, he knows everybody, and half of them are his family. So I wasn't sure if that was the same
Not
case
family, but I'm known.
Yeah. I think I mentioned it before, but we were at the restaurant in Hudson, and he's like, I talked to him last week, and he goes, "Yeah, there was probably 5 or 6 of my cousins were there," and I was like, "Well, why didn't you say hi?" And he's like, "Oh, I kind of like give him a head nod." He's like, "We see each other all the time, so it's not a big deal." And I'm like, if I saw my cousin at a restaurant, I'd be like, "Oh my God, like I can't believe you're here." And he's just like, "Hey,
not good enough."
Like, I'm going to see you in a couple of days anyway. So like, there's no need. But yeah, this is a small community for how large it is. Yes. And that's awesome. So thank you everybody for listening, and we'll see you on the next one.